Hello and welcome to the 9th lesson in Spiral 2, and it is recognizing linear relationships. So the goal, I want you to be able to demonstrate understanding of identifying which graphs relationships are linear. So going right into the note here, recognizing linear relationships. I want to fill in the following chart for the perimeter and area of the figure in the following diagram. So again, perimeter is distance around the outside of an object. So frame 1, the perimeter is 4 units. The area is 1 unit. 1, 2, 3, 4, 5, 6, 7, 8 for perimeter. Area is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for my perimeter. Area 1, 2, 3, 4, 5, 6. And the last one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The area 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Can we fill in the remaining values? Okay. Can we see a pattern that will allow us to fill in the next two values? So I look here. I went up by 4. What happens if I go up by 4 again? 8 plus 4 is 12. Does the pattern continue? 12 and 4 is 16. So we know that we're growing by plus 4 each time. So we know the next ones would be 20 and 24. On the other side, let's see what's happening here. So we went up by 2, then we went up by 3, then we went up by 4. Okay, I can see the pattern. We have enough terms to decide the pattern. So that's plus 5, and that's plus 6. So that would give me 15 and 21. So which chart, okay, so I'm looking down here, which chart shows a linear relationship? How do you know? Well, we don't at this point. So why don't we go to a graph? Because what is a linear relationship? A linear relationship means a line is involved. So let's plot our points over here. So we're going to have our perimeter is the y-axis. So perimeter and frame number. All right, so I'm looking at it. I got to go up to 6. So just each square is worth 1. And up the y-axis, I have to get up to 24. So let's go by 4s. 4, 8, 12, 16, 20, 24. So if we go up by 4s. All right, so we plot our points. I'll switch colors just to be cool. 1, 4. 2, 8, 3, 12, 4, 16, 5, 20, 6, 24. So when you look at those dots, if you were to put a ruler on that, what conclusion would you draw? I would say that I could put a ruler through there. Hey, that's not a ruler, that's freehanding. We don't want to do that. We have rulers for a reason. So I will use my line function. There we go. I think that's pretty good. So I would say that this one is definitely linear. All right, so let's graph the other one, see what happens. So again, frame number, and I can go up by 1s again. 1, 2, 3, 4, 5, and 6. Now we're going to go up by area. Got to get up to 21. Let's go up by 3s. So 3, 6, 9, 12, 15, 18, 21. Plot our points. 1, 1. So it's going to be way down here. 1, 1, 2, 3. 3, 6. 4, 10. 5, 15. 6, 21. All right. So I can try the line option. You can take your ruler out and you can see not going to work, right? Because I can't really draw a line to go through the points. So I don't think it is a line. And I think if I was to use my artistic skills here, I can draw a nice smooth curve through it. All right. So this one is non-linear. So what's the difference between the two? So of course in class we'd have a discussion, but you're watching the video. So if we look at our pattern. This one's linear. What do you notice about the pattern? It is the same each time, whereas on this one, it is changing. So to answer the question at the bottom here, which chart shows a linear relationship? So frame number, frame number versus perimeter is a linear relationship. So that being said, with that being a linear relationship, each what do you want to call this? Each growth, or each, let's not start with the word each. The pattern of growth is a constant. Okay, so the pattern of growth is a constant. Okay, so we can see that every time it was a +4. So if we can find a pattern of growth which is a constant, then we know we have a linear relationship. All right, moving on to the next one then. This is what we call first differences. First differences are rate of growth. All right, that's all we're really doing. We're checking for how is the rate of growth changing. So the first difference is a relationship between the y values. To find it, take one y value, subtract the other. It's just basically finding the pattern of the steps. So I've already tipped you off as to how that works. All right, so if we fill in the information that we had here, so 4 going up by 4s, so 4, 8, 12, 16, 20, 24. The first difference, I just don't draw in this third column, I just write it like I did on the first sheet. It's going to look like that. And on the other side, 1, 3, 6. So 1, 3, 6. So it went up by +2, +3, +4, +5, and +6. So there we go. So we know that if our first differences, all right, so our first differences, and I'm going to write this in here because I don't like, first differences is a long thing to write out. So this is what we do in the math world. First differences equal FD, fire department. All right, so first differences are these two columns. All right. So complete the following sentence. First differences for a relationship are constant. All right, if your first differences are constant or the pattern is the same, then you are dealing with a linear relationship. First differences for a non-linear relationship are changing. Okay, they're always changing. So that's how you tell the difference between a linear and a non-linear relationship, because graphs are easy. If it's a line, it's linear. If it's not a line, it's non-linear. If you have a table of values like this, that's how you tell the difference. Growth is constant. So a couple of examples for us to go through. So on the third column, I don't really care. I just want to see you looking at the pattern. So we draw the arrows. So 5 to 6 is 1. 6 to 8 is 2. So right away, I'm going to say, oh, this is nonlinear, but you need to check. There's a catch here because this is what EQAO is going to do. You got to make sure that this side is going up by 1s or the same amount each time. All right, because they're going to throw a trick in, okay, to mess with you. But as soon as this is, you see that change, so therefore it's nonlinear. All right, so maybe we'll start with our examples. Let's check to make sure the x's go up by the same amount each time. So it's going up by 1, by 1, by 1, so we're good. The other side, -4 to -1, increase by 3. -1, if I add 3, I get 2, plus 3. Those are the same, so therefore linear. That's supposed to be an R. Don't judge me. Okay, example C. I'm going to check the x's again, because they will trick you on EQAO, so just be careful. Checking this, well, I went down 1, well then I went up 1. These are not the same numbers. -1 and +1 are not the same, so therefore non-linear. All right, and the last one, let's check. Okay, so this is going up by +2. We check again. Okay, it's going up by +2, +2. Okay, so we're okay. So as long as it's going up by the same amount, we're okay. 8, we have to subtract 4, have to take away 4, have to take away 4, and there we go. It is the same, so therefore it is linear. Okay, so that's what we're looking at. We're checking out to see if those rates of change in our charts are the same. If they are, it's linear. If not, they are nonlinear. So moving into our final example, this pattern was constructed with square tiles. Copy and complete the table recording the first 6 frames. So we'll fill it in over here, 4, 5, and 6. So we want to do frame and area. So the first frame had an area of 2, 1, 2, 1, 2, 3, 4, 5, 6. The next one, 1, 2, 3, 4 by 1, 2, 3, so it's a 12. Okay, let's see if we can find a pattern here. So to go from 2 to a 6, we added 4. 6 to a 12, we added 6. What does that tell me right away? Okay, so we have a non-linear example here, non-linear relationship. If we are to guess at what the next one's going to be, all right, it looks like our differences are going up by 2, so I would anticipate that one's going to be a +8. And that one goes up by 2, so then it would be a 30. So there's our first 6 frames. And you can do this with your pictures as well. All right, so it looks like you are surrounding your original one. So we surround those guys. And then change the colors. Here was the original. So that original gets surrounded again. So you can continue the pattern to confirm. All right, so copy and complete the table. We did that. Determine the first differences. We did that. Is there a relationship between frame number and linear area? Okay, so down here for B, nonlinear. The first differences are not the same. All right, so we did that. Graph area against frame number. So we need to do a bit of a graph here. So we're going to put area, frame number. So we went up to 6. Let's go every other square is 1, 1, 2, 3, 4, 5, 6. The area went up to 30. Every 2 squares, let's say, are 5, 5, 10, 15, 20, 25, and 30. If we plot our points, so we had 1 and 2, so that's going to be about there. 2 and 6, there. 3 and 12, be somewhere in here. What am I on? 3 and, oops, did I skip one here? 2, 6, 12. Oh, I skipped one. So, not that it really matters. So, fixing that up. 3, 4, 5. So 4 and 20. 4 and 20 is right there. 5 and 30 is right there. So you can see that the line is not going to work as shown. We got to draw a curve, freehand a curve to go through it. And you can check with your ruler, take your ruler and you see, can I match up my points? And you can see that it doesn't work, so it must be a curve. All right, if you have any questions with that, make sure you ask your teacher for clarification, and they will give you a hand or clear things up for you. Good luck, and we'll see you in the next lesson.